Let's look at this interesting geometry problem. Let ABC be an equilateral triangle. Let extend side AB beyond B to a point B. So we're basically doing three extensions. And so this is going to be the smaller triangle ABC. We have that this is C prime, this is A prime, and this right down here is B prime. We want to find the area, the ratio, that A prime, B prime, C prime, this larger triangle, to the smaller triangle, just ABC. We know that these are both equilateral triangles, and it's almost as if we took this small triangle and sort of spiraled it out to make this larger triangle. So first we make it bigger, and then we slightly like spiral it or rotate it, and then it becomes this bigger triangle, but we want to find the area. So since we're only looking for the ratio, it doesn't actually matter what ABC is. So I'm just going to set it to some like nice number like 2. So let's just say the side length is 2. And so then we can like draw this in. We know this is going to be square root 3 because that's how the triangle is. This is square root 3, 1, 2 for a 30, 60, 90 triangle. And so the area of ABC is going to be 2, which is this bottom part, times square root 3 divided by 2. So the area of ABC is just square root 3 because it's 2 times square root 3 divided by 2. And so now we know that this is 2, and the key part of information here is that AA prime is 3 times CA. So, well, that's right here. And so the same thing with all these other sides. So AA prime is 3 times CA. This is 6. This is also 6. This is 6. And so each of these three triangles right here, so like this triangle, and this triangle right here, ACC prime, are all the same triangle. So we can just multiply by 3 at the end. So to find this, we have that CA prime is 8 times C prime C is 6 times, well, it's 1/2 times 8 times 6 times the sine of this angle right here. So I'm going to call this angle like alpha. And since we know that this is 60, we know that alpha is 180 minus 60 equals 120. And so this is sine alpha. And so 1/2 times 8 times 6 times sine of 120 degrees, which is square root 3 over 2. And so, I'll just take the 2's out. So this is going to be 4. So this is 12 square root 3. Each one of these triangles is 12 square root 3. So to find the big one, we multiply that by 3. So we just counted all these triangles so far. Now I want to add in this smaller triangle. So we add in a square root 3. So it's 37 square root 3. That's the area of this entire thing. So 37 square root 3. Cancel these out. We get 37 to 1. Or we just get 37, which is 37 to 1. Pretty simple problem.